Hello, welcome, and a very good evening indeed. And today we are talking about this device. And this is a pretty vintage, really vintage, so-called multi-programmer. It is for reading out and programming different erasable or non-erasable, definitely programmable ROM types, be it EPROMs, EEPROMs, or even flash chips, microcontrollers, all kinds of chips that have some kind of non-volatile memory on board and that you need, for example, for cards like this. This here is a card which is called the XT Compact Flash Lite version 4.1, and I built one of these about 2 years ago, but the success was not perfect because the compact flash socket here is actually pretty tiny and hard to solder. So I thought I'd do another one, and it's this one. And I will do a video about this because many people like me try to solder the socket and fail. And by now I've learned a few techniques and this thing works now. I just need to cut a slot in here to make the compact flash card fit even with a bracket. But the second thing that you need is something to flash this chip with. Normally you would just put the chip in here and use a DOS tool to flash the chip via the ISA bus. That's very possible on most machines. However, my current 486, which I wanted to use to program this, recognizes that this is an empty EEPROM and it says there's no ROM here, and I put my RAM in there as well. So basically this chip is invisible until somebody writes to it. So this is a kind of a chicken and egg problem. So I needed a multi-programmer, and a friend of mine, he said, I do have one at home and I can't use it on Windows 10 anymore because it uses a parallel port. And the USB to parallel converter doesn't work, and some other problems with low-level hardware access in Windows 10 said for him, yeah, this trusty old thing, which is probably 25 years old or something, I don't know. There's a serial number, but I think it doesn't have a time code, date code. Maybe when we'll open this. Yeah. So I said, yeah, no problem. This is the Galep-III. It still has Windows 3.1 software, and I have a Windows 3.1 PC, the 486. I can use this to flash the chip. So that's great. So today we will set up the software, and we'll also try to refurbish this thing a bit. As you can see, it is heavily yellowed, and I think this will be a nice case for retrobriting. You can see how yellowed this case here is. And also, you can use it on batteries or with the power supply here. But, yeah, a battery leaked in here. So we will try to clean this up, either with vinegar or I perhaps just solder in a new battery lead, because I have a bunch of those for various reasons, because you can run things like these little kits off of them. You see it's the same connector here, so maybe we just solder in a new one and make it just brand new. But definitely this will get a good cleaning, a bit of retrobriting. I think we can take off the sticker here and see if, yeah, I think it's still white under the plastic. Yeah, here you can see what the original color was. It was pretty much just white, but it yellowed over the years and decades. And of course, yeah, but it's still working. And yeah, I would say we should clean it now and disassemble it, fix everything, and then get it up and running under Windows. So let's go. And here it is, open. And as you can see, it consists of two PCBs. This upper PCB here, which has Xilinx XT 3142A, no idea what that is, maybe an FPGA, maybe a microcontroller, and some other stuff that I don't know, 5812 EPF, and this stuff here looks like RAM, I don't know, TPIC, that sounds more like a programmable interrupt controller. I don't know, I have no idea what these are, but yeah, it's interesting. And this part down here, which is probably for the parallel port interface, I see a bunch of Series 78 chips, 78C7, 74HCT132, that's the 74 series logic chip. Yeah, boy, I have no idea. There's some big fat inductors on here, some big fat capacitors. They do look good, and I don't see any corrosion from the battery, which is good. So the terminals are soldered on here. The wires look okay. So maybe we'll just use some vinegar on that, because I think it's probably only the connector. And let's face it, I probably won't use the battery on this thing. Let's see, I'll stick this into vinegar and then we'll see if it gets any better. Yeah, let's take this off. But otherwise it looks in very good condition. I'm wondering if we can remove this. Okay, it's screwed down. So let's remove these additional screws. But for the retrobriting I will have to take out the PCB, and that means I'll have to desolder the battery connector anyway. So I think we'll do just that, and then we can even replace it or use the refurbished connector with the vinegar. So white vinegar will remove this. It's not battery acid, it's actually alkaline. So acid will neutralize the alkaline crystallization here and hopefully clean up the thing. And otherwise we can just simply replace the lead and the connector. So this looks pretty nice. Yeah, we can't get that out. So that's the underside. It also looks okay. Yeah, all good. Okay, I rinsed off all 3 pieces of plastic, and while they still have some scuff marks and things, I think most of the grime is gone. And now we are off to the retrobriting, and you can see I already put some cling tape down here. And for those of you who don't know, all white or grayish or beige plastics will yellow over time because there are flame retardant chemicals in the plastic which react over time or discolor the plastic. But you can sort of reverse the process. There are different approaches, many or most of which involve hydrogen peroxide, which is known from, you can see it here from the barber shops. This is 12% hydrogen peroxide cream, which is usually used for coloring your hair, basically, making it blonde. And it will also work on plastic. I will take one of my anti-static brushes because they are cheap and I can apply the chemicals with that. I'm wearing gloves because this stuff is pretty aggressive and you shouldn't expose yourself too much to it, which says a lot about coloring your hair actually. And this cream is actually the cheapest stuff that I can get. I also have 3% solution, which is much weaker, but it's also more expensive, and it's nice for things like keys that you just throw in. But let's try this. And usually you also use a lot of sunlight and or heat to accelerate the process, but today I want to try leaving it overnight on this little tray here, You should use something that's not of much value, because this peroxide will of course discolor or interact with all the materials that you have. So I will leave this overnight and we will see tomorrow how it turned out, if having it here in a moderately warm room is enough basically to get this going. And just for reference, this looks even more yellow in person. You can see here on the inside it's what it looked like originally, and this is the discoloration, and we can then see if it works. I will wrap everything up individually so I can massage it in the evening a bit and in the morning, because if you don't apply it quite evenly, you can get some marbling effects, which I don't care much about with this piece. But if we are going to do other stuff like one of my monitors or the Amiga, then I want this to be more or less perfect. Okay, let's put the cream onto all the pieces and leave it overnight. Okay, everything is wrapped up. The cream is on the plastic. Hopefully it's enough, but we'll see that in the morning. So let's leave it overnight and we have a look tomorrow. So it's 2 days later actually. I have cleaned up the 9-volt battery connector with some white vinegar, as I said. And this one here has 2 rounds of bleaching or retrobriting, because overnight the wrapping was okay. It improved a little bit, but not by that much. So this morning before I went to work, I plastered it all over in hydrogen peroxide cream once more and put it out onto the terrace. It was a relatively sunny day, so after, I don't know, 9 hours in the sun, or especially in the heat, it's actually looking pretty good. If I put this together, you can still maybe see a slight discoloration here, but it's way better than it was before. One thing that I have to say is that the printed logo here has suffered a little bit. There seems to be some kind of plasticky material that's not liking this procedure very well, but it was broken before, scuffed and scratched, so yeah. But still, I think this is a definite improvement. Before it was really yellow and now it looks almost factory new, at least from the color. So I will solder back on the battery connector and reassemble the whole thing. And then we'll test it out with Windows and try to read and program a bunch of EPROMs. Alright, so here it is, the complete refurbished Conitec Galep-III multiprogrammer. And let's take it for a spin, and we will try and read and write those EPROMs for the CF adapter, right? And for that we will use Windows 3.1 on the 486 PC, because, yeah, using retro hardware to program retro EPROMs, of course. Let's do it. The program uses the Install Shaded Wizard, a very common setup program for Windows 3.1. The program is just 2-point-something megabytes when compressed and a little bit more when installed. Funny enough, it adds a program group for itself, but also puts the help file into the startup. So whenever you launch Windows, you will see the help file, which is a bit annoying, but can be very easily mended. After the installation, the program will start up and you can choose which device you want to use. And by device, we are talking here about EPROM, EEPROM, flash, microcontrollers and a bunch of other things. You simply select which device type, which manufacturer and which chip. Here we see the EEPROMs and we have an Atmel AT28C64, but actually we have the B variant, which is also supported, so we will simply select that. Then you hit OK to choose that device and a new file window will be opened. After that we can press F6 to actually read out a device, and I have one which contains already an XT IDE BIOS, which is working, so I want to make a copy of that to my empty EEPROM devices. And this was already it. It's a pretty small thing, so reading it out is actually very fast. Here you have it. You can watch at the hex dump basically. And yeah, it looked like it worked just fine. You can write this image or some other image to a new chip by pressing F3, which gives you a similar dialog to the readout dialog, and we press OK here as well, and it will write and verify the programming, and once successful say device programmed, and that's already it. It takes just a couple of seconds to write one of those chips. All in all, the program for the Galep-III is pretty unobtrusive, easy to use. It looks a bit dated, of course, because it is dated, but it works well, doesn't crash, and I must say this makes this device very, very useful indeed, especially for us in the homebrew scene where we have EEPROMs to burn for XT IDEs, or maybe even for the Snark Barker and similar devices. Alright, so that's some EEPROM successfully read and written using the Galep-III. I think this is a pretty useful thing to have. On eBay they appear not that often, but they still go for quite a bunch of money. You can get cheaper devices like the TL866, but these older ones like the Galep-III, they can program very old ROMs because they support, I think, programming voltages of up to 14 volts or something, which newer models sometimes don't, or some very old designs. So they do have their usefulness still, and even some more modern things like Atmel microcontrollers and stuff like that, they can do that because the Galep-III was supported until very, very recently. So yeah, it's a very useful tool to have, and I think this was a pretty nice success. It looks quite nice now, not that yellowed, it works fine. I think it will see a couple of years more, many years more of service than probably even the manufacturer expected of this little device. But that's it for today. Thank you very much for watching. Please leave a comment or like and dislike the video depending on how you liked it actually. Make sure that you subscribe so that you get notified of new video releases, and if you want you can always support me on Patreon if you have the ability, or Ko-Fi or PayPal. Everything is down there in the video description. But most important, stay healthy, and I hope to see you in the next video. Bye for now.